start with what is Spark, and then we'll come to the PySpark part. So basically, Spark is nothing but it's an environment. Like we have an OS. So if you take a system, we do have Windows 10, and inside Windows, in any version, inside Windows, we have this file management system, and we have this MS Paint default services. Like if I click on this, we will see multiple services. Like photo is something we have, the paint is something we have. So these are all like some um, basic applications that we will get inside the Windows OS environment. So you are getting the point, right? Like, so Spark is similar to that. Spark is an environment, and inside Spark we have this Spark session, and we do have Spark context, and we will be handling the data in a data frame format. So data frame format in the sense, data frame is a table like structure. So basically it will be having rows and columns, and so these are like Spark is an environment which creates, I mean, Spark will create the environment for us to work on PySpark, or like if you want to handle things on, there is a terminology called RDD, which will be focusing on later on, but I'm just saying as of now. So RDD, data frames, and Spark sessions, Spark context. So these are all the basic things that we'll be working on inside Spark environment. So Spark is something which you can imagine it as an environment. That's it. So Spark is an environment, basically. So inside Spark, once you set up the Spark environment, we have this thing called Spark session. So there is a piece of code. I'll put it right now. So it looks a bit complicated, but it's you will get it once you start working on it regularly. So this is the first set of code we will be writing whenever we want to work on PySpark. So if you want to work on PySpark, you have to set up the Spark environment first. So that is what most important is. So PySpark builder dot master. So I'll explain each of the lines. Local app name demo dot get or okay. So what I have done here is I told you that whenever we want to start a Spark, we have to start a session. A session is something you can imagine like this. So we are starting a class and we are doing a session right now. So in order to start a session like that, we will be connecting through a virtual environment, or we will be connecting offline through a class. So this class is an environment, our team is an environment, and you can compare the same thing to Spark. So Spark is an environment, and we are initiating a session. So each session is initiated like how we are doing it right now. So same thing, we will be calling this keyword, which is Spark session, and then this builder is nothing but we will call the Spark session and we will ask to build it. So build a session. So that's what we are telling to the system through this way. We are saying to the system that, hey, please create a Spark session for us and just build it. So this is this is what the first line is telling us. And this slash, there's nothing but it is telling like you can go to, I can write the same code like this, like in a single line, Spark session dot builder dot master dot app name dot get or create. I can write the entire 4 lines of this code in a single line. So in order to improve the readability in the sense you can now see the code properly compared to how it would have been if I written the same thing in a single line. So it will be a bit not good. So that's why I have this backslash is nothing but I'm just saying that I'm going to the next line. Whatever code is the next line, you can consider that also for this same thing. And dot master. So this is something you will get it once we will deep dive into Spark architecture, which we'll be doing that next. And master is whenever we let's say whenever I say that we are going to create a Spark environment, one thing is very mandatory. That is, we do have a master node and we do have like worker nodes. I'll tell you what is a master node, what is a worker node, what is a cluster and all moving forward. But those are the ones who are actually going to create the work. They are nothing but in general form, it's a CPU basically. So how many CPUs you are going to use? And if you take a CPU, whenever you try to go and buy a laptop or you try to buy a desktop, we have this what do we say? We will be, even if you look at the phone, we'll be looking at RAM and how many GB of RAM do we have, and what is the storage it is having. So these are like specific configurations that we will look into a phone. If you go with a laptop, the additional information we'll be covering is the cores, like how many quad, is it a quad core in the sense whether it has 4 cores or whether it has dual core. So these are like some information we will look into while we are planning to buy a laptop. So if you will try, maybe if you try next time, you will see in the configurations page, we have this information like how many cores it has. So the core is what we call it as nodes here. So that we will cover later on, but on a high level. So that is what um, a, a master or local refers to. So master is something which will handle, which will be the leader, and the worker nodes are the ones, or we can call it as a manager, and the worker nodes are the one which will be handled by, which will do the exact code basically. And coming to this app name is nothing but we are creating, giving this session a name. So the name is demo. That's it. So that's the keyword we are using. And next thing is I'm defining, if we already have a session, just go and get that. If the session is in the name of demo, just go and get it, or else create a new one. That's what we are telling this thing. If we already have a session, right, why do we need to create another one? So there is no point in creating another one, right? So if we have a session already, just get it or else create a new one. So that's what we are just saying to the system. Or basically, we can call this as a configuration for a new Spark environment to be created. Whenever we are creating an environment, we might need some requirements, right? Like prerequisites or something. So these are the lines which defines the prerequisite. And this star is nothing but um, I will tell you. I will tell you in maybe in the while working on the Spark architecture. So whenever we want to work on PySpark, first we need to create a Spark session, and after that we have to create the Spark and I mean Spark environment. So once it is done, we will start working on the PySpark part, and that's how things will happen in the code also. Like whenever you try to write a logic, first you need to define the Spark session or the Spark environment, and then you will start working on the PySpark part. So this is how we start the session, and this line will be there all the time. Whenever you start writing a code, this line will be, this set of code will be there all the time. So that's why I'm just giving at the beginning itself, so that you, whenever you start writing a code, right, you'll be definitely writing this set of lines. So next thing is, what is PySpark? So why PySpark is faster compared to um, other ETL tools? PySpark itself is going to do the transformation. So why PySpark is faster than a framework? So Informatica is a third-party tool. So why it is faster and what's the exact reason behind it? The one more thing is that PySpark is 100 times faster than these things. So what is difference that PySpark holds that others don't? So the main criteria is that you might have heard the term called cache. Cache is nothing but whenever you try to access a website, or whenever you try to access something very frequently during the process, so that that set of work, or that set of result will be stored in the cache memory. So I'll show you one example here. Um, just a minute. So if I try to access the same link again, Just a second. If I refresh it, it will be gone. So I guess this is the one copy link address. So if I add this line of code, so this is the same link that this is our class sessions link. So I have already accessed it. If I try to click on that, it will open up immediately. If I try to open the same link, maybe for the first time, it will take some time, maybe 1 or 2 seconds delay in it. But this is for something which is on a smaller level or on a smaller scale. But if I try to do the same thing, right, in an like let's say for the first time in an high level, like we'll ignore that for now. But the main thing is that what catch here is whenever we are trying to access something, I mean very frequently. So instead of going to the server and get that information, we will save this links. I mean this Teams link in a local in our local machine. Local machine in a sense. Now this link has been saved in my laptop. It's not with the Teams Microsoft Teams servers now. So if I try to go and access this again, it will not go to the server. It will just go to my system, take the information, and provide us the result. So that's a major difference between a catch and when you try to access the same link for the first time. So there is a we are cutting down basically. We are cutting down the time taken for accessing the same information again and again, because we know, so that's what catches basically. So instead of going to a server and taking the information, we already knew that this information will be needed regularly. So in order to reduce the time there, we will create a session, I mean we will create a catch there for that result, and we will store it in our local machine. So next time when you go and try to access the same link, it will not go to the server. Instead it will go to my local system and take the information and process it. That's the difference between a catch and that's the main thing of a catch, what we call data which has been cached. And PySpark basically uses the same thing. So where is exactly the catch information is being saved? I told you that it will be inside the local. So where is it exactly inside the local? So inside the local, in the sense, we store this information in RAM. So there is a thing you might have heard during your school days, that we have RAM and ROM. RAM is read access memory, read only memory, and read access memory. Like there are two things. RAM is something, it is temporarily available. So whereas in ROM, so I told you we'll take the example, phone example itself. So if you see, if you are planning to buy an iPhone, you look at the RAM. So if the RAM is 8 GB and the storage is 128 GB, so storage is what we call it as ROM or OM. And this storage, it's kind of a permanent one. It won't delete once you switch off the phone, or once you like get out of the particular app. So it is not going to destroy that memory or like that. Whereas if you go with RAM, that particular storage or that particular information which is being stored in that RAM memory will be there, maybe till that particular application gets over, or maybe if you turn off the phone or try to restart it. So these are the cache memory usually goes and sits there, and RAM is nothing but it will try to access it as fast as possible, because I told you all the cache memories will be stored in RAM. If you are using an application, so if you are using an application, so and if you try to access same thing again and again, this RAM is what is going to store a cache memory. And if you are needed for the same result for the second time, it will go to the RAM instead of ROM to give us the memory. So I will write it down, like RAM stores cache memory, and ROM stores the actual data, but this is permanent, or we call it call this one as non-volatile. Non-volatile in the sense it won't go. This is permanent, and stores cache, but this is temporary.
Sorry.
Yeah,
Sorry to disturb, sorry. Sorry, here, as you know, all are experienced only. We don't want to spend time in kind of these things. You can go in some other concepts, like why it is actually fasting, because I don't think catch is only reason for because Spark is faster than Informatica. Because Informatica also using the same catch logics. So it can just go to the high level architecture. Then we can have any queries during that time we will arise.
yeah, I'm getting the point. Maybe you might have known it, but others also should know, right? And also the same time, this is
Yeah,
needed,
you
like
can you can yeah you can
architecture.
check the you can check their opinion as well. But this was I'm feeling because we have only sort of time. We want to grace uh, more and more. That's why.
Yeah, I'm like these bits and this kind of information is needed whenever you are going to work with Spark architecture level. If I go straight away to the architecture, you won't understand why it is being like if you can use Informatica, right, then what's the point of using PySpark? Then both are going to do the same thing. It is going to process the data and it is going to transform the data.
No, yeah. That's what
So you need to know why,
we want.
right? That's why I'm explaining this thing, because if you don't know why it is being used, then um, there's no point, right? So if I straight away go to that part, others might feel bit confusing on that. This is needed for next step. That's why I'll try to reduce it. Don't worry. I'll try to take much lesser time than what I'm taking right now. I'll take that as an input. Yeah. So since you guys, so I'll go with the Spark architecture then, and this is what catches actually. So we will be um, accessing the data, and this catch concept is what PySpark is using, but the read and write time is lesser here. We won't be writing to the, I mean, the read and write operation is lesser in PySpark, whereas the read and write operation is more in Informatica and other third-party tools, because they used to write to the disk whatever information that they are getting, and they have to read it from the disk rather than from the cache memory. So that is why RAM is for, they are reading it from ROM rather than from this RAM memory. So that's the main reason why Spark is being faster compared to those areas. So now get into Spark architecture as you guys are asking for. Just a second.
Hari, before going for Spark architecture, the first step is building the session, and is it a case sensitive? The
Yeah,
com-
Python is case sensitive. Yeah. So this is like, yeah, basically we will be writing this code inside a, though it is a Spark environment, under the hood, it is still a Python code basically. So Python is a case sensitive. So this is also a case sensitive one.
okay.
Yeah.
Sorry.
Yeah.
Before start, I have a question.
Hmm.
So now you are going to explain the PySpark architecture together with Hadoop, right?
Okay. You're asking I
Like,
mean, Spark architecture?
no. Yeah, Spark architecture you are going to explain, right? How
Yeah.
you are going to explain, because we are not familiar with the Hadoop itself. So if you
Mm-hmm.
are explaining the standalone Hadoop architecture, then move forward to Spark. How that Spark build on top of that Hadoop, then it's better for us. Betterly we can
Okay.
understand.
So yeah, you got so Hadoop is a different technology. Spark is a different technology.
Yeah,
Hadoop is
but
completely HDFS and it comes under a different what you can say. Hadoop is something which is the foundation for Spark. It is the first technology that is being used in big data. Spark is the advanced one. If I combine both, right? So I'll tell you, like Spark will be, I mean, Hadoop will be using nodes, and each node will be holding 128 MB of data. So this is what Hadoop architecture is. It will take a long amount of time, and it will actually eliminate the need or the information needed for Spark actually. If it will elongate the session, HDFS is completely different, Spark is completely different. They are not even using the same principle. Hadoop is like divide and conquer. That's what Hadoop is using. And Spark is that it will divide it based on the number of clusters that is being available. So manually we'll be defining how many clusters, I mean, how many worker nodes will be needed, and how many master nodes will be needing, and how many, what you can say, how many clusters we will be needing. Whereas in HDFS or Hadoop, the concept is completely different. So Hadoop is slower compared to Spark. If I mean, compare both. I will explain you what is Hadoop architecture also. That there is no, I mean, that's a good question though. You what you asked. Anyway, I'll be going to explain that. But if you are asking me to go in depth, right, in Hadoop and Hadoop's concept, Hadoop commands, so that is a complete different scope. And this is
No,
like
no,
really
not
out
in
of
depth.
scope in terms of
Not in
price.
depth, in high level, at least in high level, how Hadoop is running. On top of that, how MapReduce concept applied in PySpark to improve that Hadoop. Likewise,
Hmm.
I want to understand.
Okay, okay, got it. Okay, you basically want to know how MapReduce model is working in Hadoop and how it is differing from. Okay, fine. So first, so that is the only question you had, or you told you'll be having a couple of questions, right?
No, no, no. That's it.
Okay, okay. So I'll just add Hadoop. First, I'll explain Spark architecture because that's what we are looking at, and then I'll take the Hadoop and I'll explain the difference between this and that. Because yeah, so first thing is that we'll be having whenever you take a Spark architecture, there are majorly few components being involved, which is very mandatory, as I told earlier. The first thing is that the master node, a cluster basically. A cluster is a combination of master node and worker node. Okay, so master node in the sense a node, as I told earlier, it's a code, basically a CPU. Master node and a group of worker nodes together. If we put it together, it's a cluster. And you can imagine the same thing in an real-time scenario as an you work in a project, you have a manager, and the manager has set of employees to do the task. So manager will be getting his work from the client. So he will be getting the requirement and he will be distributing it to the workers. Similarly, in Spark also, we will be getting the input data. So the input data might be come from many different cloud services like we have AWS, GCP, and Azure. Inside AWS, we might get it from S3. S3 is like um, a bucket, storage bucket basically. So all the data will be sitting inside that um, particular bucket. So we can consider, I mean, you can compare that one with the normal file system, how we have local disk like C, D, E, and if you click on C, it will go to the next folder, and if you click on that, it will be moving forward. So like same architecture will be there inside AWS bucket, and we'll be connecting AWS to our PySpark. So connection is something that is being involved here. So on the top level, we have a Spark code. Maybe I'll use Paint here. I have a PPT, but it's in the other laptop. I'll take that after the session. But for now, I'll just explain the concept and then I'll move forward to that. And after the break, I'll take that one. So let's say we have um, a master node and the worker nodes. The master node, um, I mean, we have the Spark driver. Okay, the Spark driver is the one which is going to drive the program. Whatever code that you are writing right in the PySpark. So you have written like 500 lines of code, and inside that 500 lines, you have the logic, you have the transformation, and everything. So this file will be provided here in this stage. So this is the driver, and in this driver, what it does, it will connect. The driver will be connected to the next one, which is the cluster. Driver, we have driver and then we have executors. So driver, in the name itself you can see driver is going to run the program. So whatever lines or whatever file you have passed here, it will be given to this one, which is nothing but an executor. Executors are nothing but worker nodes basically. So master will be sitting here inside the driver, and I mean driver will be there. It will generate, it will collect all the code, all the requirements and the resource allocations. So how many nodes are needed, how many masters are needed, and how much data we are going to process. So all the kind of metadata basically. So all kind of metadata will be captured, and driver will be using that information as well, and based on that it will allocate resources like master, worker nodes, or executors, tasks, so these kind of things. So first step is that we have driver, and this driver takes these kind of informations, metadata, and then it gives us the resources. And once the resources are being provided, master, this worker nodes comes into picture. Master node, what it is going to do, it will divide, the task. So that's what you can imagine, the same thing in a real time corporate project also. I will explain that as well. But if you divide this thing, the task will be provided. I mean, we'll be breaking down, let's say 100 GB of data into 10 GB, and imagine that we have a driver, and this driver has captured 100 GB of data, that it got to know that there are 100 GB of data that we need to process, and we have provided the same information, like how many nodes are needed. So that is what we have shown here. Like in this code, this master is something which tells us that I need one master, and this local is nothing but, this local refers to my system, whatever I'm using, and then it will tell us how many nodes I need. So the star refers to all the cores that is present in my laptop. So if I, let's say if my laptop is having 4 cores, then local star will represent 4 cores in my local system. So take all the 4 cores in my local system, and then which will be acting as, that all cores will be acting as worker nodes, and in that one will be qualified as master node. So if you see, we have totally 4 cores. One will be a master, and the other 3 is going to be worker. So we have this information has also been provided in our code. Once the driver gets all this information and resources are being allocated, the data will be divided, or we call it as partitions. So data will be divided into 100 GB of data. Let's say we have 3 nodes here. I'm going to divide it into 3 partitions, because, like, let's say I'm just having 3 worker nodes. So all I can do is I can either uh, this parallelism is there. So if I have 3 workers has to do the work parallelly. I cannot wait for one worker to complete, and then another worker will come and do the work, like that. I cannot wait for that much of time. I mean, PySpark is actually doing parallelism here. I mean, parallel is a thing called cluster manager, or resource manager, basically. I just missed this one. So what happens here, like as I told earlier, like some terminologies we have not seen, like in-depth things like executors, um, and the cluster manager and all. So as I told earlier, there are the components that involved at the time was master node, driver, worker nodes, and the tasks that they are going to do. So you see here, we have master node, and both are in the same location. So that's why I have given it in like in this manner. So whatever information that driver, the code that we are providing, right? So driver process that one. So that's why I kept that one inside. As I told earlier, it will be getting the metadatas, and master node will be interacting with the cluster manager. So cluster manager is something which came in our picture, because as you can think, this one has, you have to ask the resource, right? Like you need this amount of resource, and you have informed the master node, the master node, that you need these many worker nodes, and this is the type of data you are going to handle, and you are going to process it. So this interaction will be done between driver and master. Once master gets a requirement, the number of worker nodes that it needs, so it has to go and ask someone for that resource, right? Like let's say if we need 10 cores, so it knows that it needs 10 cores, but whom it will ask. So that's why cluster manager came into picture. So we can call it as resource manager. So what it will do, master node will request 10 worker nodes from resource manager. So resource manager, what it will do, it will go and allocate 10 resources to 10 cores to master nodes. So this is how allocation will be happening. And then the actual task. So executors, inside worker nodes, right? We have these executors. So even in a core, we do have executors. So same concept applies here. This is like in depth. I'm explaining how the data we are getting, and how each worker node are getting their data, and these executors will define, I mean, the worker nodes will define the actual task, and inside the worker node will be doing the task. But inside the worker node, we have executors, and those executors will be doing the actual processing of data, like whatever logic we have been used. Like let's say there is some function called map function, plat map, those kind of functions. So if we say like we want to do some map functions on top of that data, these executors will do that, and the actual task will be defined by the worker node. So the executors will just follow the instructions. That's it. So the result of this executors will be given back to the worker node, and from the worker node, it will be sent back to the driver, or to the, I mean, to the master node, and master node will be sending it back to the driver. Driver is the one which is actually having the final output. So this is, if you see the diagram, you can understand it clearly, like how things are interconnected. Maybe this example will also help us even more. So I'll just decide, like let's say you have a new project requirement, and just imagine that you're working in a service based one, and we have one manager with 3 employees. That's a requirement that it was, and they were asking for. So manager, you think this one as a driver, or you can think this one as a manager. Maybe manager will be, sorry, a master. Master will be a better option. So what happens here? This manager is requesting, as I told earlier, right? Master node will be requesting for some course. Similarly, you can correlate this with that one. So requesting for 3 PySpark developer. So we know that we need 3 PySpark developer, but whom we are going to ask for? So we'll be asking it to the HR, and HR will try to hire 3 PySpark developers, and they will be allocated under this manager. So which in our case will be a master node. So these 3 worker nodes, what they will, I mean, you can compare them with that one. And PySpark developers are the one who are going to do the actual task, and their output, we can, their output will be combined together and shown to the client. Say whatever stories, like let's say we have one long task. That long task will be divided between 3 developers, and their 3 developers output can be put together and shown to the client as the final output. So this is how you can think Spark architecture with in real-time scenario. And executors will have, so there is a hierarchy. First comes the cluster. So in terms of architecture, first comes the cluster, and then this whatever I'm saying applies here and between master and worker nodes. So because this is needed for doing the calculation. So later on we'll be doing some mathematical calculation, and this will be helpful on how many resources we need, or how many cores we might need, how many executors we need. So those kind of things. So clusters, then comes a nodes. A cluster is nothing but a group of nodes, is what we call it as cluster. And then after node we have executors, cores, and maybe this might master node. I mean, node itself is fine. Yeah. So this is how actually this structure looks like. So a group of cores will form an executor, and a group of executors will form a no worker node, and I mean, a group of nodes will be called as a cluster. So this is needed whenever like let's say you want to calculate how many executors we need based on the information, like how many nodes are there and how many cores are there, but you need to know how many executors that we want. So in this architecture, I mean, this hierarchy will help us in calculating those values. You might need to calculate this also whenever you try to manage or allocate resource for a particular amount of data that needs to be processed. So this is the hierarchy and the Spark components. So as I told earlier, the Spark driver is a central control node of a Spark application. So the driver is the one. So you are in. If I'm interacting with the system, driver is the intermediate. So I will talk to the drive. Whatever code will be provided from my end, will be sent to the driver. Driver will be sending it to the Spark one, and the interaction happens between both of us with the help of Drive. And it maintains information about the Spark application such as user code, as I told earlier. DAG is nothing but it's a job. So since some of you are in ETL field, you know what is a job. A DAG of RDDs. RDDs we will cover it up next. I mean in next session, and execution plans. So we have, whenever a code has been given, Spark itself will have a predefined execution plans. So like let's say we have HDFS. We will talk about that a little bit now. So HDFS follows map reduce model. Map reduce model in the sense it will divide the data as we are dividing it now, and and it will process all the data parallelly, and then it will combine the data at the output, and it will send us a result. So like same concept, 100 GB of data being divided and being processed parallelly and then combined together, and then we'll get the result. So then what's the difference between Spark? I mean, what's the difference between PySpark and HDFS model? While PySpark is being faster than the existing one, is that simple thing. That's what I was talking about, the catch concept. So you can take catch on all the things, but PySpark's in-memory computation is what it makes stand out from the rest of the tools basically. So in memory, in the sense, whatever data that you give or whatever data that we are going to process will be, if you take the other tools or if you take with an HDFS, it will go and interact with the disk. That's why I was explaining a bit about technical technical parts of a system, because it will interact with the disk. So whenever you try to read from a disk or whenever you try to write to a disk, it's a time consuming process actually. So you have to go back to the driver, I mean to the disk, and then come back to our HDFS node. So this is a time consuming process, and this is what the issue earlier we had. While PySpark, it is not going to do the read and write operations to the disk. Whatever happens, it will happen with the RAM. And that's what I told you, right? Like it will happen with the cache. So that is the major difference between an HDFS and a PySpark. And that's why it is way faster than the other existing traditional tools, basically. So everyone, that's the only difference. I mean, not the only difference, that's the main difference between a PySpark and the HDFS, their capacity to handle huge amount of data at a faster rate. And so coming to this part, driver is something that's what acts as an intermediary between me and the end user. I mean, me and the system. So the driver program interprets user code, understands the user code, converts it into task, and coordinates the execution of this task on the cluster. So execution plan, I told you, right? So whatever I told was the execution plan, and the remaining third point is that I have told you already that it understands the code, converts the code into task, and also coordinates the execution. That's the main thing. It is not going to perform the thing; it is going to coordinate it. That's it. Whereas executors are worker nodes in the Spark cluster responsible for executing tasks. So each executor typically runs on a separate JVM. So in under the hood, I told you, right? We have we will be writing the code in Python, but even the Python is written in Java. Okay, I think my battery is low. 1 second. So even let's say the Python is being built from Java, like we call it a C Python. So this Java virtual machine is what we are using to process the data. Whatever, like I told you, right? These codes are built on Java code only. That's the reason I was explaining a bit there. Like JVM are used to process the data, but whatever code that we are going to write will be in Python. So how many interfaces are being involved in a simple PySpark transformation? So there are multiple stages involved, like the way we write the code, the way system understands the code, and way the machine is being used. I mean, the type of machine being used and which language they have been written. That's all. That those are the things that are being involved. So at the end, it's just Java that is going to do the process. So executors are worker nodes, and each executor, as I told, it will process data. But every executor has a JVM. That's what the main concept here is. If I talk about this executor, this executor has a JVM, Java Virtual Machine. That's what it is. And executors run computation and store data in memory or on disk as needed. So if you process the data being stored in memory or on disk, it is either the case that whenever you are processing the data, it will be stored on disk. But it will be whenever you're storing the data, it will be on disk. But whenever you're trying to do some process, right, all the data from the disk will be taken once and will be stored in RAM. You understood the difference, right? Like it will be there. If it is permanently sitting on some machine, it will be there for a while in the memory. But when you need to process that set of data, it will take the data from the disk and puts it in the memory, in the RAM, and then it will start doing the process. So during that, while processing it, there is no need to go back to the disk. It will just go back to the cache, or it will go back to the RAM, and it will take the data. That's it. They communicate with the driver program and are assigned tasks to execute. So as you told, the communication will be with the driver, or actually here it needs to be they communicate the driver program. Yeah, the program, in the sense, executors actually communicates with master and this one to the driver. I just need to assign these things. Executors can run multiple tasks concurrently and manage resources such as CPUs and CPU cores and memories. So I have told you this particular hierarchy, right? Executors, and inside that executors we have cores. So executors can run multiple tasks concurrently and manage resources. So we have executors, and inside the executors we have tasks. So concurrent task is that parallelism is what they were talking about. So if we want to do multiple tasks parallelly, I have just defined everything as one here. So it can process two tasks. If the executor has two cores, it can parallelly process two tasks like that. So that's how, like, the thing here is. If you see inside one executor, if we are having three cores, then it can process three partitions. That's what it actually meant by. So coming back to this one, um, executors can run, and that's what executor is about. Cluster is simple. Directly, you can say that in the name itself. It is managing or providing resources. The cluster manager is responsible for managing resources across the Spark cluster. So some of the famous cluster managers are Apache Mesos, Hadoop Yarn, and all. The cluster managers allocate resources such as CPU cores and memory to Spark applications and monitors their execution. So that's it. That's what cluster manager executor. So main reason behind is, like, you need to understand a little bit about what cores, RAM, ROM, and these kind of terminologies. So it will be easier for you to understand theoretical part, and because mostly PySpark has huge amount of theory to understand, then only you can go and write the code. But in terms of code wise, it will be very simple. It won't be that much complicated once you understand how things will work at the back end, so that you can write the code according to it. And so this is what architecture looks like. So any doubts here in Spark architecture? Any doubts from anyone? So I guess we are good then. You can reach out to me. Like, if you do have any doubts, you can ask me later also. So I'll share the PPT. You can sit in the chat. Just download it, because once we disconnect the call, right, this will be okay. Geeta has left the chat, and that's what I felt someone was missing. So I'll just, okay, I can't able to send this today. Okay, you all provide your email IDs to me in the WhatsApp. I'll send that PPT to you. And you can look into it whenever you have time. Now, Spark architecture is done. And next thing is let's talk about parallelism is done, lazy action and transformation. So this is very important. So any doubts till now? Are we good to move to the next topic? Okay, okay, fine. So transformation. Um, so let's say we told that in ETL process we have extract, transform, and load. So transformation is where we'll be doing all the um, changes. Here. Before transformation, let's talk about RDD. RDD is something. RDD is that full form of it is resilient distributed data set. So the name itself it suggests that. So data you asked about fault. I mean data failure, right? I told that RD. I mean it will be replicated. The data will be replicated and all. So those things will be done here. So that RDD is the concept where data will be distributed across multiple nodes. If you are working in an RDD data frame, like we have um, basically three types of data formats in Spark, especially in PySpark. We have RDD, we have data frame, and we have data set. So what is RDD first? So RDD is that nothing but it's just the data, and it won't be in table structure. Like the data won't look like in a table like format, but it will be in a simple what we can say simple. It won't even have a structure. Basically the structure won't be that much. It will be somewhat in different way than it looks like how a data frame looks like, because data frame you can simply say that it's a table like format where it will be having rows, columns, and things, but in RDD it won't be the case. And here the data will be distributed across multiple nodes. That's why the name itself we can see resilient distributed data set. So resilient, like we won't be losing the data even if that failure or job failure happens in one partition in one worker node. The other worker nodes are not affected, right? Because they are not dependent on each other. So only the worker failure, I mean the work I mean the failure has happened in one. That's a good example you asked. So that if that fails there in that worker node one, then the job, I mean I told you like we have multiple nodes, so how we are going to handle it, it depends on the mode of um, how we are going to handle the error. So that we will be defining there. There's different modes being applied. And most probably it comes under while writing it. So while let's say you want to write, we have this code called spark dot write dot format. So these kind of things, in that you will define how what kind of mode you want to write. So if I say the mode properly, it tells that how we are going to handle the issues, also how we are going to handle the failures also. So and also at the same time the same replica has been there in another data set. So that is one of the biggest advantage of Spark. So the name itself, you can see that the RDD is holding those kind of features. Like you can take the replica, so those things what I have explained now. So then comes the data frame, the other data type. So as I told earlier, table like format with rows and columns, and data set is again it's kind of a partial RDD and partial data frame. It doesn't have predefined structure, but at the same time, the data will be sitting inside the data set. So you can just go and access that, take the data, and you can convert that into RDD or data frame or whatever you prefer. But most of the time, whenever we are going to do the logical transformations or whenever we are going to PySpark, write the PySpark code, so RDD and data frame are the two where we'll be doing all these things. Data set is simply we'll be storing the data in some place, and we won't be doing any transformations using data set. We'll be doing all the logical transformation using RDD and data frame. And yeah, so these are three formats. And now coming to the transformation part, we have two types of transformation. So first, what is transformation? So transformation, when it comes to RDD, so let's say I told you we'll be working on either RDD or data frame, right? So let's say we are working on RDD and we have done some transformation. What happens in RDD is that, let's say I have one RDD. So I have one RDD and here I'm trying to, let's say I have some data inside this RDD1. And if I want to do some transformation on RDD1, how I will do is RDD1 dot, I'm just writing a simple code here. Okay. So RDD, let's imagine that RDD1 is holding some data. I'm trying to do some transformation, and map is one of the transformation that we will be a keyword that we will use for transformation. I'll explain what is map later on, but this is the code. And what basically I'm trying to do is I'm just trying to multiply it by 2. Whatever data is inside the RDD, I'm just multiplying all the data by 2. So once it is being multiplied, it won't affect the RDD1. I mean, the existing RDD is still the same. Like, let's imagine that RDD1 is holding data 2, 3, 4, I'm sorry, 4, 5. RDD1 is having data like this. If I apply this logic, it won't affect the RDD1. I mean, the RDD1 or the existing RDD cannot change or it cannot be transformed. That's the main concept here. Whenever you do an operation or transformation on an RDD, the existing RDD does not change at all. The existing RDD will be the same. So whatever the transformation is that you are applying here, it will be loaded here into RDD2. It still RDD1 is going to be like this, whereas RDD2 will be like this. 4, 6, 8, 10. So this is what a major difference. Like if you apply same transformation on a data frame, right, it will change. It will change the existing data frame itself. But whereas if you do a transformation on an RDD, it won't change. It won't affect the existing one. It will change only the. It will create a new one instead. It won't change the existing one. It will create a new one and store the result over there. So that's the major difference between an RDD and transformation while doing in an RDD and a data frame. And transformation, you know that whatever logic, business rules we have applied, so that comes into picture. So this is kind of a business rule we can say, and this is the transformation we have applied in this scenario. Now coming to the other two, I mean, two types of transformations are there: narrow transformations and wide transformations. So before going into this, so we have this concept called the partition, which we have spoke about earlier. So partitions are nothing. We will be dividing the data into a set of groups. So we will be dividing the data into a set of groups. Like let's say we have 1 GB of data. We will divide it into, let's say, 5 partition. Then it comes like 200 partitions each. And similarly, same thing happens here. Whenever you do, so the entire transformation concept lies in the partition only. So narrow transformation is that whenever you change, like let's say we have 4 data, right? Let's imagine we have 2 partitions. So 2 partitions in the sense 2 bytes of data. 2 data goes to one partition and other 2 goes to other partition. Okay, while doing this logical transformation, what happens here? That first partition will be handled like, we'll take this PPT also now. It will be easier to compare. That's what we prefer. So let's say you have an idea, right? Like how many amount, since you'll be running some jobs on a daily basis, you know, like how much data it is going to be. So based on that data, you will you will manually define how many cores you need and how many executors we need. Basically, um, we will provide that information in here itself. Like let's say I need if you need 5 worker nodes, you can just directly put it as 5 here, and it will go and like take 5 resources and assign it to us. So we will define it manually, and this calculation is being done. We'll see that that also, like how we will do the calculations based on the amount of data that we are going to process. But yeah, in to be short, we can manually define it. If we don't know how many amount of data that we are going to process, maybe if we are trying to run a job for the first time, you might not have idea of how many amount of GB you will be processing the data. So for when you run it for the first time, Spark will manually Spark will automatically do those things. So it has a lineage plan where it will look at the data and it will look at the transformations, and based on all those details it will automatically create a plan and allocates resources according to it. So yeah, so once you run the job for the first time, you will see like how many amount of data we are processing in the output or in the insights page, what in the PySpark. So based on that, we can now change things accordingly. So yeah,
Mm.
so in short, we can do both. PySpark can also automatically take and run the job if you don't have any idea about the data, or if you do know what kind of data that you are going to process. Because mostly we will know like the amount of data that we are going to process. Based on that, we will manually define the amount of resources that we need here itself. And if you ask me about how we do the partition in the code, that we will see while, but basically it's during the write operation. So whenever like
Oh,
whenever we read the data, we will write the data obviously. So during the writing of, while defining the right part of the code, we will define how many partitions we need, and not even how many partitions. It's like, let's say you are taking the year column. So how you will define is that partition by year. So if you'll do like that, it will partition data according to year. Like let's say if we have 5 years of data, so we'll get 5 partitions. That's it. Like that's how the partition will be. Partition is nothing but, in terms of short, sequels group by is what partition here is. That's how you can correlate to things each other. And if you want to, you can do repartition also. Like let's say, if you partition it by year, we have 5 partitions. But imagine that 2020 has 2 million records, whereas 2021, 2022 remaining years have 1 million records. So 2020 is holding double the record of 2020 other years, right? So here partition is
yeah.
not equal. So in that case, what we will do repartition. So that also will define in the code. Like we partition by this, and then again we'll put repartition by the number of partitions you want. Like let's say instead of 5 you want 6, you can just put it as dot repartition 6, or we have other function called coels, so you can put it as coel 6. So you can use coel 6 actually. It will reduce, it is used to be reduced. Yeah, so repartition is what you can use to increase the partition size, which we will cover later on basically, but that's how
Oh,
things will go.
so, so Hari, now you're explaining coolers and something, right? Those are inbuilt functionalities in Spark, right?
Yeah,
We are
yeah.
just calling that functionality based on our requirement.
Yeah, based on requirement, we just go and call the function. That's it.
Okay, Hari. So you told if we are allocating that node manually, then
Mm.
we are going to do some calculation based on that only we are giving those information, right? So
Yeah.
while calculating, we should consider our availability, resource availability as well, right? For example, you have different resource. For example, you
Mm-hmm.
have only 4 GB RAM computer, but I
Mm.
have different. So I should consider that as well while calculating.
Um, if you take cloud, right? Cloud is like on-demand one, so there is no need to worry about the amount. The resource you have. But at the same time, billing is also something important. But I guess the costs are less most of the time. The That is not the case. Like if you're working on a mainframe or on-premise a server, so there is a limitation obviously. So in that case, you need to imagine. You need to consider the amount of resources that you have. But if you are working on cloud, or let's say on Databricks, or if you're working on AWS, Azure, or any cloud platform, so that resource that you have is not the case. Like you can no need to worry about that part.
Okay.
Yeah. So I guess any other doubts? Okay, we'll proceed further. So lazy evaluation. So the main thing that PySpark has an advantage is this lazy evaluation process. So this is very simple. So since we spoke about transformation and actions, so lazy evaluation depends on these two things. So imagine that you have written all the lines of code. Okay, like around 90 to 900 lines or 1000 lines of code you have written. And what has happened there is you are not calling the end result to the driver. Only if you sending the results back to the driver, it will be useful for other like let's say it will be useful for us, because if we send the result back to the driver, it will be visible to us. So it will be useful for us. If you are not, or it will be used by some other systems that are integrated with it. The main concept here is when the result is not being used by someone, so there is no concept of doing it. So that's what lazy evaluation considers. So let's say you have done all the transformations here. So let's say RDD, these set of transformations you have done, but you have not called, like let's say RDD2 dot collect. So this is an action operation. Okay. So if you are not giving this action, action operation. So if you are not calling this function RDD2.collect, whatever operations that you do here is of no use. So PySpark, what it will do, first it will go and see whether it has any action operation in the code. If there is no action operation, right, the entire PySpark code will not execute. And that's the main concept of lazy evaluation. So first it will go and see whether this collect operation, any operation that sends the result back to the driver, or sends result back to makes it visible to us. So if that kind of operation is not there, this entire transformation won't happen at all. So the first step of PySpark is to check whether the action operation is there or not. Once it encounters it is there, it will start go and execute the transformation operation. That's how the execution plan will be set. These and all we won't set it out. PySpark inbuilt itself, it has this nature. So there is no, we just need to understand that lazy evaluation is that PySpark is doing this thing. So that is what the main concept is. That's why if the you can see the purpose of why lazy evaluation is being used. If it is not there, if you are not sending the result back to the driver, then don't execute it. So that's the concept of lazy evaluation. And yeah, so this is one of the key features, and many interviews they might ask, and but in real time you just need to know, that's it. Like, because PySpark will take care of it, but if you see, like sometimes if PySpark code is not getting executed, so these can also be the case. Like you have not made sure that the result was sent back to the driver. It's not just collect. It might be return something, return the data or whatever operation which fails to send the result back to the driver. That's it. Just we need to be aware of that part. And I guess base evaluation transformations are done. Maybe 1 second. You'll just look at some basic calculations. Maybe a calculation we'll do it tomorrow. So for now, we'll complete with this part. So you all send your email IDs in WhatsApp. I'll just forward the PPT to you. And if you have time, you can just watch over that architecture. And yeah, we'll discuss a little bit about DAG then. That's more than enough as of now. Any doubts in this till now in lazy evaluation, or you guys are good? Okay, I'll consider that no one is having doubts. Okay. So DAG is nothing but if you are in data engineering field, you know that we have a job. A job is nothing but a set of transformations. And there is another term called orchestration. Orchestration is that we are not going to have one job. So we will be having multiple n number of ETL jobs. So this n number of ETL jobs will be handled by an orchestration tool, example Airflow. So in Airflow, we call job as a DAG. So don't get confused when someone says DAG, because it might be the case most of the time I faced earlier. So job is that it's a set of transformation. In ETL tools, we call it as a job, but in Airflow, we call it as a DAG. And DAG is nothing but directed acyclic graph, which shows that it is not cyclic one. It is an acyclic. That's the main uh, concept here. If whatever transformations you do, at the end, it won't come back. I mean, it's not, the set of transformation is not in a loop. That's what one thing. And I guess today, I guess more than enough. Tomorrow we'll start with the calculation and we'll set up this Jupyter environment. So after that we'll start working on it. If you have time, just look on how to install Jupyter. It's very simple. Just go to this website or else I already have here. I'll show you how it looks like first. So this is how it looks like, Jupyter notebook, and you just need to go to Anaconda, download, click on this website, and just provide your email ID. So once you go right, it will ask for installation. Just download it, and once you have downloaded it, it will look like this. Anaconda Navigator. If you open that one, you have multiple applications inside that Anaconda. So just you need to install Jupyter there, and that's it. You are good to go. Just need to do some configurations, like you have to install PySpark and all. That way, I'll show you tomorrow. Maybe like simple only. Try to open up the command prompt.
Hariharan?
Yeah.
Yeah, I have one doubt. So why we are using the Jupyter rather than like we have more IDs for PySpark, right? Why we are
Mhm.
choosing the Jupyter?
Mostly you can prefer like whatever you want, but the idea behind is that only simple advantages UI will be good, and the same UI will be applied on most of the services. Like if you see take Databricks, it will look exactly the same as Jupyter, and even on cloud services also, if you take their in the PySpark environment, it exactly looks almost the same as this. So it is like user friendly, and also at the same time it will gives you confidence if you work on the same UI, right? So that's why I preferred it. Other than that, not big difference. Like it's up to you. If you want to work on other things, it is also fine. But this is somewhat I have been working on a regular basis as it was user friendly. That's the only reason.
Okay, okay.
So requirement already satisfied. Okay, I have already installed it. So let's see. Python was known for